Imagine a place so dry and empty that maps color it mustard yellow. Now imagine that same place growing potatoes. Millions of kilos of them. Sounds like a headline or a dare, right? But this is real. In a desert region covering about 42,200 square kilometers, nearly 12,000 farmers joined a project that turned 4,000 acres of sand into potato fields. At peak, those fields produced up to 430 kilograms of potatoes per acre, adding up to roughly 1.7 million kilograms a year. Why is that jaw-dropping? Think about a backyard garden. If you forget to water it for a week, most plants wilt. Now scale that backyard up to thousands of square kilometers with only 250 to 440 millimeters of rain a year. That's less than many semi-arid places get. And imagine coaxing crops out of it. It's like teaching a cactus to grow apples. This story starts with a simple, blunt question. How did they do it? The answer won't be a single magic trick. It's a mix of long-term planning, digging into soil science, clever use of water when it's available, and the stubbornness of people who refuse to let the land be only sand. In this video, we'll walk that path, from the sweep of sandstorms to the lab tests, from small pilot plots to fields that feed villages. We'll look at the methods, the numbers, the human cost, and the human payoff, and whether this approach can work somewhere else. Next, we'll lay out what was at stake, why turning sand green mattered so much in the first place. Before China's potato fields made headlines, the land itself was fighting a very different battle against people. For decades, desertification was one of China's toughest environmental problems. By the early 2000s, more than 2.6 million square kilometers of land had turned to desert. That's over a quarter of the entire country. Imagine an area larger than Argentina, once green and productive, now reduced to blowing sand. Desertification isn't just about losing scenery, it means losing life. In northern China, strong winds would pick up loose sand from barren regions like the Mu-Us Desert, hurling it across cities and farmland. These sandstorms could last for days, blotting out the sun and leaving layers of grit on everything: cars, houses, even inside people's lungs. For farmers, it was disaster after disaster. Crops buried, livestock suffocated, homes abandoned. Every storm meant lost food, lost income, sometimes lost lives. People who lived there weren't strangers to hardship, but this was nature fighting back hard. The soil no longer held together. The roots that once anchored it were gone, and every gust of wind peeled away another layer of hope. It wasn't just about farming anymore. It was about survival. By this point, the question for China wasn't, can we grow food here? It was, can we stop the desert from swallowing everything? That question pushed the government and scientists to launch one of the largest environmental projects in human history, a fight to reclaim the land itself. Next, we'll see how that national mission began, and how decades of tree planting and land restoration laid the groundwork for something as strange as growing potatoes in the desert. When your backyard keeps turning into sand, you don't just grab a shovel, you start a campaign. That's exactly what China did. Starting in the late 1970s and accelerating after 1988, the country launched massive anti-desertification and afforestation projects, basically a long war to bring life back to dead land. The idea was simple but enormous. Stop the sand, plant the green. Over the years, this turned into the world's largest environmental engineering effort. China set up 41 demonstration zones for desert control, places to test and refine methods before spreading them nationwide. The most famous project was the 3 North Shelter Belt, often called the Green Great Wall. It aimed to plant trees across a 4,500-kilometer stretch, roughly the distance from Spain to Iran, to block sandstorms before they reached major cities. The numbers are staggering. Since the late 20th century, China has planted over 100 billion trees and restored about 280 million acres of degraded land. Satellite images even show patches of green expanding where dunes once dominated. In some areas, the government also banned grazing or construction to let nature recover, protecting over 26 million acres of land under strict conservation rules. But this wasn't just about trees. Each new forested patch slowed the wind, trapped sand, and brought back insects, birds, and moisture. Over time, deserts that once marched forward began to retreat. Locals started to use a proud new phrase: green advancing, desert retreating. Still, this was only part of the story. While trees stopped the sand, they didn't yet put food on the table. The next challenge was even bolder. Could these same deserts actually grow crops? That question led scientists and farmers to one of the harshest places in northern China, the Mu-Us Desert, where they would attempt something no one believed possible. After years of planting trees and watching green slowly return, Chinese scientists began to wonder, if trees could survive here, what else could? Could a desert, once stabilized, actually produce food? That daring thought sparked a new experiment in one of the harshest places imaginable: the Mu-Us Desert, a region in northwest China that had long been one of the country's major sources of dust storms. The Mu-Us Desert wasn't just dry, it was bone dry. Rainfall averaged only 250 to 440 millimeters a year, barely enough to keep grass alive. The soil was loose and sandy, unable to hold water or nutrients. Most experts would have said it was hopeless farmland. But scientists decided to test a new idea called the minimally invasive planting method. The goal was to work with the desert, not against it, to disturb the environment as little as possible while giving plants a fighting chance. It started small. In 2016, engineers and farmers planted drought-tolerant saplings to see how they would adapt. When many of them survived, the success gave researchers the courage to go further. By 2018, scientists were sent to conduct in-depth soil and climate studies. The data surprised everyone. Certain areas actually had hidden potential for crops if moisture could be managed correctly. Later that year, the local government approved a bold plan, a $350 million project to turn part of the desert into farmland. The first real test began in 2019. A group of about a dozen agricultural experts teamed up with local farmers to transform just 20 acres of sand into test plots. They didn't use fancy technology, only local tools, small irrigation systems, and patience. The first harvest wasn't impressive by normal standards, about 3,000 kilograms of potatoes in total, or around 150 kilograms per acre. But it proved something world-changing: the desert could grow food. That small experiment flipped a mental switch. If a few acres could yield potatoes, what about hundreds? What about thousands? Next, we'll uncover how they made that leap, the clever techniques that turned dry sand into living soil, and how they solved the biggest problem of all: water. If there's one rule every farmer knows, it's this: no water, no crops. And in the Mu-Us Desert, that was the single biggest problem. The region's annual rainfall couldn't even fill a small swimming pool per hectare, and groundwater was far too deep to rely on. So, how do you water potatoes in a desert? The answer came from a very old idea: flood irrigation, but used in a clever modern way. Chinese scientists realized that during certain seasons, nearby rivers would occasionally overflow with floodwater. Instead of letting that water rush away and disappear, they learned to guide it into selected areas of the desert. The floods soaked deep into the sand, but more importantly, they left behind layers of silt, fine particles full of minerals and organic matter. Over time, this silt built up into a thin but fertile layer, turning loose sand into soil that could actually hold moisture and nutrients. Think of it like teaching the desert to breathe again. Each flood brought a fresh pulse of life, a bit of clay, a bit of water, a bit of hope. Slowly, the land started changing color. The pale yellow dunes darkened into patches of brown, where roots could finally take hold. It was nature's recycling system, managed by human hands. The scientists combined this with the minimally invasive planting method, which meant planting in small holes or shallow pits that trapped rainwater and reduced evaporation. They also tested drought-tolerant potato varieties, strains that could survive with less water but still produce decent yields. The goal wasn't to copy traditional farmland, but to invent a new kind of agriculture suited to extreme environments. The results were remarkable. Within a few growing seasons, the once barren land was supporting green vines and healthy potato plants. Satellite images started to show faint green patches appearing in areas that had been blank sand only years earlier. For the locals, this wasn't just an experiment anymore. It was proof that even a desert could be persuaded to grow life. Now that they had cracked the water and soil problem, it was time to think bigger. Could this small success be scaled up into something that would feed thousands and change lives? Next, we'll see how this experiment expanded from a handful of fields to thousands of acres, and what it meant for the farmers who worked that land. Once scientists proved that potatoes could grow in the Mu-Yus Desert, the small test plots quickly evolved into a full-scale agricultural project. Beginning in 2020, the team started expanding beyond the original 20-acre experiment. With support from local governments and research institutes, they prepared thousands of acres of sandy land using the same flood and silt method. By the time the project reached full swing, they had transformed nearly 4,000 acres of desert into potato fields. This wasn't a one-lab success story. It was a community movement. Around 12,000 farmers joined in, learning new desert planting methods and sharing traditional knowledge about soil and water management. For many of them, this was life-changing. These were families who had once watched sandstorms destroy their crops year after year. Now, they were harvesting healthy, market-ready potatoes. Some farmers' annual incomes reportedly climbed to over $10,000, a dramatic leap from what was once one of China's poorest regions. By 2023, the results stunned even the experts. The desert potato fields were yielding up to 430 kilograms per acre, producing a total of about 1.7 million kilograms of potatoes in one season. That's not record-breaking by normal farmland standards, but considering this was sand a few years earlier, it was extraordinary. More importantly, the land that grew these crops also became more stable. The roots of the potato plants helped anchor the soil, reducing dust and sand movement. Each harvest didn't just feed people, it helped heal the land itself. Local villages started to transform too. New irrigation channels were built, roads were improved, and young people who had left for cities began to return home to work in these new green industries. You could say the desert wasn't just producing potatoes, it was producing hope. But the story doesn't stop here. As China's desert potatoes made headlines, scientists and officials from other desert nations began to take notice. Could this model work elsewhere? In the Middle East, in Africa, or in other arid parts of the world? Next, we'll explore how this Chinese success caught global attention, what lessons other countries hope to learn, and whether desert farming might really be the future of food security. When news of China's desert-grown potatoes spread, it didn't stay local for long. In early 2023, agricultural experts from Saudi Arabia, the United Arab Emirates, and other countries visited the Mu-Yus Desert to see the project firsthand. These were nations that understood deserts better than anyone. Vast, sun-scorched regions where importing food was often easier than growing it. But China's success offered a new possibility. Maybe the desert itself could become farmland. For these visitors, it wasn't just curiosity, it was about survival. Many desert countries face the same challenges: limited freshwater, fragile ecosystems, and growing populations that need secure food supplies. If a technique could make sand hold water and nutrients, it could rewrite what's possible in some of the world's driest places. China's combination of flood diversion, silt enrichment, and low-disturbance planting looked like a practical, scalable model, one that didn't rely on expensive, high-tech irrigation systems. However, scientists were careful not to oversell it. They warned that this approach depends heavily on local conditions, especially having seasonal floods or water sources nearby. Not every desert can replicate that. Turning sand green is as much about smart geography and long-term planning as it is about technology. There's also the challenge of balancing agriculture with ecology. Too much water diversion could harm river systems, so each region must find its own balance. Still, the MUUS project offered something precious proof of possibility. It showed that with science, persistence, and cooperation, even the harshest landscapes could yield life. For countries searching for ways to fight climate change, food shortages, and land degradation all at once, this wasn't just an agricultural breakthrough, it was a glimpse of a new future. But what does that future look like? Could this kind of green desert farming really be sustainable, or is it just a temporary success? Next, we'll close the story by reflecting on what this achievement truly means for China, for the planet, and for anyone who believes the impossible can grow from dust. When you step back and look at the MUUS story, it's not just about potatoes, it's about possibility. A few decades ago, this region was nothing but dunes and dust storms. Today, it's a living example of how science and human determination can rewrite what's normal for nature. Turning a hostile desert into farmland is one of those things that sounds like science fiction until you realize it's already happening. The achievement isn't just agricultural, it's ecological and social. Every potato that grew here helped anchor the sand. Every irrigation channel slowed desert expansion, and every new harvest brought stability to families who once thought their land was lost forever. Nearly 94% of the MUUS desert has now been brought under effective management. That's an environmental comeback on a scale few countries have ever pulled off. But it's not a fairy tale. Even the people behind the project admit there are limits. Desert farming is demanding. It needs careful planning, steady funding, and constant monitoring to avoid overusing water or damaging fragile ecosystems. The message isn't turn every desert into farmland, but rather, learn how to live smarter with the land we have. The MUUS success proves that with patience, technology, and local participation, humans can cooperate with nature, not just fight it. And maybe that's the real moral of this story. Progress doesn't always mean conquering the desert. Sometimes it means listening to it, finding its rhythms, using its strengths, and helping it hold life again. The people who planted those first potatoes weren't chasing records. They were proving that even the most hopeless ground can offer hope back. So as we look ahead, the question isn't whether China can grow potatoes in the desert. It's whether the rest of the world can grow the same kind of vision. Because the deserts of today might be the farmlands of tomorrow, if we choose to learn from the land instead of giving up on it. If you found this story inspiring, make sure to subscribe and turn on notifications. We'll keep exploring how human creativity is reshaping the planet, one idea at a time. Because sometimes, the best stories of growth start in the most unlikely places.